In this video, we're going to take a look at drawing Lewis structures for various molecules. Here I have written some general guidelines to help you in your work in writing these. So we'll hit these as we go through the examples. So let's start with the first example. So let's choose a different color. So let's go with nitrogen. Remember, nitrogen is a diatomic molecule, so nitrogen gas is always found as N2 instead of just the atom N by itself. So if we wanted to draw the Lewis structure for nitrogen, let's just go ahead and start with here. So sum up the valence number of electrons. If you look at the periodic table, you will know that nitrogen has 5 valence electrons. So we have 5 valence electrons, and there are 2 of them. So 5 times 2 gives me 10. So we have 10 electrons basically to place or to play with in nitrogen. So the second guideline says write the symbols and connect them with a single bond. So let's go ahead and do that. So the symbol is N, and another symbol was the other N, so we'll go ahead and connect them with a single bond. A line represents a pair of electrons or 2 electrons, but this is where they are bonded together. So number 3 says complete the octets of atoms that are bonded to the central atom. We don't really have one particular central atom here, but we can go ahead and complete the octets. Or we can attempt to. So we've got 2 electrons here. We know we have a total of 10 that we can play with, 10 to place. So this is 2, 4, 6, 8, and 10. So those are our 10 electrons that we've placed in this molecule. Alright, so number 4, any electrons that are left over goes on the center atom. We don't have any electrons left over, and actually it looks like we don't have enough. So if we look at number 5, it says if there's a shortage of electrons, try multiple bonds. So here's exactly what we're going to do now. So in this particular example, this nitrogen is happy because it has 8 valence electrons, whereas the nitrogen on the left is not yet happy because it hasn't completed its octet. So if we were to, if this nitrogen said, okay, I'll be a nice guy, and these 2 electrons on the top I will share with you, and we will draw a line here. So this nitrogen still has the 8 valence electrons, but now this nitrogen has an additional pair. Well, this nitrogen on the right will also say, okay, well, I will take these 2 electrons on the bottom, and I will share with you also we'll do a different color here, so share those. So now if we look, this nitrogen basically has these electrons. So it's got 2, 4, 6, 8. So this nitrogen is happy because it has achieved its octet. And if we look at this nitrogen has these electrons. So it's got 2 here, 4, 6, and 8. So this nitrogen has become happy as well. But if you look, the overlap here, this is almost looks like a Venn diagram. But the overlapping electrons, these are the bonding electrons. So this is actually what's called a triple bond, meaning that there are 3 pairs of electrons, or a triple bond rather. This is an example because we have 3 different pairs of electrons that are overlapped. So if we double check, we still have our 10 electrons, 2, 4, 6, 8, 10, so that's good, and everybody's happy. So this is the appropriate Lewis structure of nitrogen. And you could have also put the dots on the left hand side and make it look like this. It doesn't really matter which side the dots are on as long as you have the correct number, and usually we put no more than 2 dots per side. But anyhow, that is how you draw the Lewis structure for nitrogen. So let's do another example. So let's say if I have an organic molecule, CH3OH. So this is actually so if we look at carbon, let's put this up here. So write symbols and connect with a single bond. So typically we're going to put the least electronegative at the middle. Typically that's how it works, but sometimes it doesn't always work out. So in this case, hydrogen actually is less electronegative than carbon, but carbons normally go in the center, and hydrogens normally go on the outside, and you'll see what I mean in just a second. So let's go ahead and sum up the valence electrons. Well, carbon has 4. There's only 1 of them. I have 3 hydrogens here and 1 hydrogen there. So hydrogen has 1 valence electron. I have 4 of them. So that's going to give me 1 times 4, which is 4. So I'll just bring my 4 down here for carbon. And oxygen has 6 valence electrons. So I'll bring the 6 down here. So 4 plus 4 plus 6. So that's 8 plus 6. that gives me 14 electrons. So I know I have 14 electrons to play with. So I'm going to go ahead, like I said, carbon normally goes at the center. Whenever you have an organic molecule, and typically it's an organic molecule if you have carbon in it. That's not always the case, but most of the time that's the case. So carbon. So we're going to go ahead and put our 3 H's onto the carbon, because like we said, hydrogen is typically going on the outside. And then I'm going to attach the O here, and then I'm going to attach the H on the outside. So let's go ahead and count up the electrons. So I've got 2, 4, 6, 8, 10. So I've got 10 electrons, and I have to put 2 more, okay, or 4 more rather. So if I put 1 here, 2, 3, 4, because I can't put any on hydrogen because they're happy with just 2, and this carbon's already happy because it's got an octet here. So let's just double check our electrons. So it's 2, 4, 6, 8, 10, 12, 14. So I have a total of 14 electrons, and everyone is happy because they have an octet except for hydrogen, but it's happy with just 2. So this is the Lewis structure for drawing this organic molecule. And this is actually an alcohol. This is called, it's a simple alcohol called methanol. This is poisonous. If you drink it, it can cause you to go blind, as it basically kills the optic nerve. But anyhow, methanol, organic molecule, it's an alcohol, so this is the Lewis structure for methanol. So let's do another example here. Let's pick a different color. So in the next example, let's do a polyatomic ion. So let's do SO4 negative 2. So a polyatomic ion is basically a group of atoms that act as one ion together. And an ion, if you recall, is a charged particle. So once again, let's just sum up the valence number of electrons. So sulfur has 6 valence electrons. Oxygen has 6 valence electrons, but there are 4 of them, so 6 times 4, that's going to give me 24, plus my 6. So I've got to look at this here. This negative 2 basically means that I have gained an additional 2 electrons. Because electrons are negative, and because I have a negative 2 charge, that means that I've gained 2 electrons. So I need to make sure to put those additional 2 electrons in counting my valence numbers. So 6 plus 24 gives me 30, plus 2 gives me a total number of 32 electrons. So that's what I have to play with, is 32 electrons. So we're going to write the symbols and connect with a single bond. The least electronegative goes in the middle. So here is where this guideline is going to help. Sulfur is less electronegative than oxygen, and we remember that by the trends because electronegativity increases from left to right across the periodic table and from bottom to top. So electronegativity increases according to this basic trend. So we're going to put our sulfur in the middle, and we'll go ahead and add the other oxygens. So we'll connect everything with a single bond, and we'll make it look like so. Okay. So now, number 3, complete the octets of the atoms bonded to the central atom. So the oxygens here. So I've already got 2, 4, 6, 8 electrons. So that's 10, 12, 14, 16, 18, 20. So this is 22, 24, 26, 28, 30, and 32. So that gives me my total number of 32 electrons. So because this was a polyatomic ion and had a negative charge or a charge of negative 2, we're going to put this entire Lewis structure in a bracket, and we're going to put a negative 2 on the outside. So this basically shows that this entire thing has a negative 2 charge. So there weren't any electrons left over, and there wasn't a shortage of electrons, so we didn't need to do any multiple bonds. So if we double check the electron numbers again, so it's 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. So this gives me 32 electrons. And like we said, the total overall charge was a negative 2. So this is the Lewis structure for SO4, which is sulfate. This is a polyatomic ion. So let's do one more example. So I'm going to get, let's see if we can get a different layer here. Alright, so the next example, let's try, let's do yellow. So the next example, let's do C2H4. So the first thing we're going to do is count up the valence electrons. Carbon has 4, there are 2 of them, 4 times 2 is 8. We're going to count up the hydrogens. Each hydrogen has 1. There are 4 of them. 1 times 4 is 4. So 8 plus 4 gives me 12 electrons to play with. So remember, carbons go in the middle for organic molecules and the hydrogens go to the outside. So if we put the hydrogens here, I've got 2 more hydrogens I need to place. I can't put them on the other side because if I were to put a hydrogen, if I were to do this, this automatically makes this hydrogen here have more than 2 electrons. So I know that I can't do that, so I have to place this hydrogen somewhere else. So I can't place it on the hydrogen itself, but I can place it on the carbon. So we'll put the hydrogen here, and we'll put the hydrogen there. Okay, so now let's count up my valence electrons. There's 2, 4, 6, 8, 10. So I've got 2 more. So let's just put that one there and that one there. So now all my electrons are on here. Everybody's happy except for this carbon here. This carbon only has 6 valence electrons because there's 2, 4, 6. But what's going to happen here if we go by the guideline, the last one, we almost don't have enough electrons, so we're going to try multiple bonds. Well, this carbon on the left is a nice guy, and it says, okay, I'm going to take these 2 electrons and I'm going to share them with this carbon. So those 2 electrons go here, they're shared. So now if you look, everybody's happy. This carbon has these electrons, which are 8 valence electrons, and the second carbon has these electrons, which are 8 electrons, and the ones in the middle are the overlap between these 2 carbons. So we still have the same number of electrons. We have 2, 4, 6, 8, 10, 12, which is the 12 what we needed, and everyone is happy. So let's do maybe a couple more examples. So the next one that we're going to look at is called ozone. So ozone is O3. It's 3 atoms of oxygen bonded together. And this is actually the layer in our atmosphere that blocks ultraviolet radiation from the sun. So let's go ahead and count up our valence electrons. So oxygen has 6. There are 3 of them. 6 times 3 gives me 18 electrons to play with. So I'm going to go ahead and draw my oxygens out like such. And then I'm going to add my electrons. So I have 2 here. I have 4. So I'm going to say 6, 8, 10, 12, 14, 16, 18. So if you look, all the oxygens except for the one on the left are happy. So we don't have any extra electrons, so we're going to have to try some multiple bonds. So what if this is oxygen in the middle said, okay, I'm a really nice guy, so I'm going to share these 2 electrons with the oxygen on the left. So those 2 electrons move to right here. So now this oxygen has 2, 4, 6, 8. This oxygen has these electrons. 2, 4, 6, 8. This oxygen has these electrons. And then 2, 4, 6, 8. This oxygen has these electrons. So the overlapping are where the oxygens are sharing the electrons, but I'd still have a total of 18 electrons, and everyone is happy. Everyone has 8 valence electrons. But what's interesting in ozone, ozone actually has something that's called a resonance structure. So that's an S. Let's try this again. Resonance structure. And basically what this means is a resonance structure means that there is a different Lewis structure that you can draw that's valid, but it looks different. So if we start this again, so let's say oxygen bonded to oxygen bonded to oxygen. So we still have 18 electrons to play with. So I've got 2 here, 4 here. But this time let's start on the left. So that's 2, 4. So we'll go 6, 8, 10, 12, 14, 16, and 18. So in this case, the oxygen in the middle is still going to be the nice guy, but instead of moving his electrons to the left as we did in the first example, this oxygen is going to move his electrons to the right. So now we've still got 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons. And this oxygen is happy because it has 8 valence electrons. This oxygen is happy because it has 8 valence electrons. And this one is happy because it has 8 valence electrons. But if you'll notice, this structure here is not the same structure as this. In the first example, we have the double bond to the left of the molecule. In the second example, we have the double bond to the right of the molecule. So these are resonance structures, meaning that they're two different structures, but they're valid. They're correct. So to write this, you would have to indicate the resonance structure. So the answer for the Lewis structure for ozone, you have to put both of these. So I'm drawing the first oxygen, or the first ozone. So this is exactly what we had at number 1. And then you're going to draw arrows, or an arrow with 2 sides on it. And then you're going to draw the second one. So I'm going to put the oxygen here, draw my electrons in the O, and the double bond O. Okay, and then I'll put brackets around this. So this shows that it's the resonance structure. So basically in nature, what this means is the true molecule of ozone is actually a hybrid of these two. So it kind of happens simultaneously. I know that's kind of weird to think about, but that's kind of the case. But anyhow, these are resonance structures. They're two equally valid Lewis structures for the same molecule. So let's do one more example. And the last one, we're going to do another polyatomic ion called ammonium, which is NH4 plus 1. So here, let's count up the valence electrons. Nitrogen has 5, hydrogen has 1. There are 4 of them, so 1 times 4 is 4. Bring my 5 down. So now this plus 1. So in the previous example, we had SO4 and negative 2, so we added 2 electrons. But because we have a positive 1 charge here, that means an electron has gone away. So instead of adding an electron, we're actually going to subtract an electron. So 5 plus 4 gives me 9, minus 1 is going to give me 8 electrons that I can play with. So we're going to put nitrogen in the middle. Even though hydrogen is less electron negative, we're going to place hydrogens on the outside. They just typically go on the outside. So let's draw in my H's. Alright, so I've got NH4. So let's count up my electrons. I've got 2, 4, 6, 8. Well, I could only play with 8. I've already got 8, and everybody is happy. So this is the Lewis structure for the polyatomic ion ammonium.